So, no, guys, I really appreciate you all coming here. It's very exciting to see such a vibrant community and so many of you already using WSO2. And what I'm going to talk about today is where we see the world going in terms of APIs, the cell-based architecture, and also talking about how we can kind of try and make our future technology fit better with the organization to become more agile. This is something I think is really, really important, is that I think agility and speed is the biggest challenge that every organization has these days. And we're just the same. Everyone is trying to fight their competitors, trying to come to market with new and exciting things. And it's all about how we can build that agility into our overall infrastructure, into our model, and into the way we organize as well as the technology. And Devika showed this slide, and I think this is really interesting. You know, I have my own personal experience of this. So my first job was as a student. Before I went to university, I spent a year working for IBM in the UK. And we were building a system which was called in those days cooperative computing. This is basically client-server before the name client-server was even coined. Yes, I'm that old. You can see the gray in my beard here. And so what we were doing was building a system that was partly on a PC and partly on a mainframe. And that was the very first signs of this disaggregation of components into smaller pieces. And why are we disaggregating? I mean, this is a kind of a 50-year story, isn't it? From mainframes down to serverless and cloud and microservices and all these small components. And what's behind it? I think there are two drivers. The first is that it is quicker and more agile to recompose these components into new systems. And so therefore you build applications faster. And more importantly, you don't just build applications faster, you evolve applications faster. This is not just the first time you build something, it's about how you evolve it. Because fundamentally, we are all, the IT industry is a sort of living example of Darwin's evolution. You know, we all know this. We are checking our code into GitHub, and we're doing an update or a pull request, and then we do a CI/CD build, and then we validate, is this release better than the previous one or not? That's an iteration, that's a generation. This is why scientists study fruit flies, because they have these fast iterations. The faster the iteration, the quicker you can evolve. So that's the first reason. The second reason is that it's much, much easier to scale and to change the scale of systems that are built as small components. Monoliths don't scale well. And these microservices, serverless components, Dockerized, running on Kubernetes in AWS or Azure, give you that ability to scale much more quickly. And I'm constantly talking to customers who put out a system and were surprised by the uptake. They learned something. They're like, oh my God, we got more than we expected. And that ability to scale quickly, to know that you can scale when you need to, is really, really important in today's world. So those are the two drivers. And I know the names on the top of that slide are all, you know, big names doing crazy scale. But the same thing I see in much smaller organizations. I see much smaller organizations needing agility, needing scale, and moving to microservices, serverless, smaller components in order to get that. And of course, as Devika said, APIs are the glue between these. So we are now, hardly ever do I talk to a developer who is building applications that are just within a single VM, within a single system, that are not talking out to SaaS applications over the network, not talking out to other services in their organization, not building systems that are inherently distributed. Is there anyone in the room building distributed apps today? I am. Go on, hands up. Come on, properly. And now, who's building an app that has no connection to any other network service? No, none of you. Exactly. So it just isn't happening. And so this is And of course, we've been doing this for 15, 20 years. I remember going to the first DCOM, Corba, RPC type events where we started out doing these network communications 20 or more years ago. But I think what's really changed is this realization that we need to do this in a managed way. And this is how I characterize it. An API is some business capability delivered over the internet, network accessible through standard interfaces, designed for access by third parties. But what's important is not just an API, but a managed API. A managed API is when you have subscription, when you offer keys and SLAs, when you do security, when you do monitoring and throttling, when you validate who's using it and how they're using it, where you manage deprecation, so you keep old versions around while people migrate, where you maintain this as a true service. And this is really, really important because even inside organizations, we saw SOA succeed to an extent, but where it failed was because of this. It failed because it lacked this ability to really treat somebody as saying, well, I don't need to know you in order for you to do business with me. I don't need you to come and sit in a team meeting. You can go to the portal and sign up. I can have an automated workflow that puts you in the sandbox, lets you test it out, and then when you're ready, moves you into a production system. So all of these kind of capabilities that help us be more independent from each other, more loosely coupled, are what are making APIs a success. And I see APIs as the products of the 21st century. So APIs are how you deliver digital value. And what's really interesting is, 3,000 years ago, the Phoenicians started buying products in one place and sitting on their little boats and trading them in others. And you'd get this boat along and it would have carpets from one manufacturer and urns and pottery from another. And we are beginning to see this with APIs. At the moment, APIs are mainly consumed directly from the provider. So in other words, there's only one hop here. The person who provides the API talks directly to the person who consumes it. But we're beginning to see aggregation of APIs, bundling of APIs. We're beginning to see reselling of APIs, particularly in the telecom industry. So particularly in telecom and finance. So for example, we see organizations who take identity or wallets and rebundle them and allow you to use a wallet with different providers and transfer money in and so forth. And so that's interesting. We have a partner called Applegate who makes a very interesting set of services for the telecoms industry. They came out of a big group in Southeast Asia called Axiata that has around 200 million cell phone subscribers. So they take APIs and they bundle them and they resell them to cell phone companies in Singapore. So they have what they call a hub that resells a whole bundles of APIs. And now they're working with Orange in the Middle East who say, well, actually, we could resell those bundles for you. So you end up with a three-way revenue share on the API. So there's a cell phone company in Saudi Arabia that's buying it from Orange, that's buying it from Applegate in Singapore, that's buying it from the original API vendor. And you're creating these federated networks of APIs. And why is this interesting? It's interesting because what it's showing is exactly the same history that we saw with trade. 2,000, 3,000, 4,000 years ago, you needed a tool, you bought it from the guy who made it, right? You swapped it with some food or something from the person who made it, and then we started trading in goods. And that made them fungible and created the whole explosion of trade that created the world we live in today. And APIs are the basis of the next iteration of that. And really, really importantly, we're seeing APIs used very widely within organizations. And I'm going to talk a lot about that because I think this is absolutely key to getting agility. So just to give some examples, StubHub was our very first API customer when we built an API product. So Devika mentioned eBay. eBay used our ESB as their API gateway before there were any API gateways. And they still use it in production, doing billions of transactions. That led us to sort of say, hey, we should build a product here. StubHub was our first customer. They used it for internal APIs first and then external APIs. They're doing around 1 billion transactions a day, every day, through our platform. As far as I know, they've never had any downtime. We've never had any downtime with eBay either. So eBay has never had any downtime with the WSO2 platform, doing billions of transactions over 10 years. Transport for London uses our platform to do a whole host of different things. This is a really simple but interesting example. London has a bit of a traffic problem, and I hear Joburg has one as well. The taxi driver, as I was coming in, said, well, it could take half an hour, it could take 2 hours. And one of the problems is just people digging up the road. So there are 30 different utility companies who have a license to dig up the road in London. And before they invented this system, none of them communicated. So you'd be literally have the road dug up by the electric company 1 week, and they'd just fill it in, and then along would come the water company and dig up your road the next week. And you'd be like, guys, why can't you just get together and do it at once? And what's worse was the buses, and didn't know about the diversions in advance. There couldn't be any rerouting. So London Transport built a system that allows, through APIs, those utility companies to connect their existing systems they use to manage their work directly to London Transport's. So it's all a seamless system to manage this. It's very cool. And what's really cool is they charge those companies money to dig up the road. They have to pay £2,000 a day to dig up the road. They put it all in a big fund, and they use that to sponsor new things. So we're trying to get them, we're organizing a hackathon with them and using that to sponsor some prizes for the winners. Jaguar Land Rover, I don't know if you read the papers today, they didn't have a good financial year, unfortunately. They've got some problems in China, but that is, I don't think I can take the blame for that. They are a WSO2 customer, and what they've done with WSO2 is really interesting because they've integrated APIs across the whole life cycle of the product. So they use it at the business end, they use it when they sell the car, but they also use it in the manufacturing plant. They've deployed APIs inside every manufacturing plant, and they use that to automate the manufacturing. And then having done those two things, they're like, here's a clever idea. If you go into the sales room and you configure a car, we can take that directly to the manufacturing plant and say, okay, you want the Alcantara leather interior and the 10-speaker stereo system. We can directly automate that the whole way through, which they've done, which is really sweet. And they're not the only company that uses us in manufacturing. So Micron manufactures chips. In 7 plants around the world, they've used the API management to improve the productivity of the manufacturing process for chip manufacturing. Every bank in Europe has had to adopt APIs over the last year. So there's this new thing called PSD2. It's a Payment Services Directive 2. And it's basically regulation from European government to say, we must open up banking so that you can be more open about your finances. So what does this mean in practice? This means that there's an app on my phone now from one bank, and I can add any other bank accounts I have into it, and I can see all my balances in one place. But more importantly, it also makes it much, much easier to do direct bank payments and debits. So Amazon are rubbing their hands with glee about this, because rather than making all the payments directly through Visa and MasterCard and paying 1.7% or whatever they pay Visa and MasterCard, they can say, we can help you in 2 clicks link your bank account directly to Amazon, and now you can spend even more money with us. And we don't have to pay anything to Visa and MasterCard. So this is really interesting. We are working with Société Générale, Crédit Agricole, but also a whole load of smaller banks as well. So G was the Bank of Cyprus, UK. The deadline for clients was March this year. In September last year, they came to us and they said, we haven't done anything. bank had been doing stuff for like 2 years preparing for this, and they were like, we're a bit behind here, guys. And we put in place a system in 3 months. We connected to their core banking application. We exposed it as secure APIs. We put in all the required consent and security that's needed for compliance, and we got the system up and running before the deadline of March. They were pretty pleased. We did exactly. Last week I was at another one in Germany, and one of the speakers was from a bank, Asiatic Bank. They do all kinds of interesting things. They do white label credit cards, sorts of stuff. They told us they did exactly the same. They did a 3 months integration with their core banking application. We'd never touched that before, into production, and met the deadline. And last night I was talking to Carl from Flash, and I didn't get his permission to put this up here, so I hope he doesn't mind. He's one of the people who's recently started using our API manager, and they're using the API manager to expose all kinds of services through devices to 155,000 businesses that use Flash device to offer services to local communities here in South Africa. I thought that was an amazing story. I was really blown away. That not just doing technology, but also helping individual startup businesses create wealth for their communities, make life easier out in the middle of nowhere. I was really excited by that. That struck me right here. So good job. Big round of applause to Flash. So as Devika said, we have a leading product here, which has been called out leader by Forrester, highly rated by Gartner. And I think what's really interesting about this is a lot of open source in the API management space, but we're the only truly end-to-end open source solution that allows you to use an API micro gateway in microservices architecture that allows you to do full portal and exposure out to the public with external endpoints like StubHub and Transport for London are doing, that allows you to do key management, single sign-on, throttling, traffic management, and also has deployment in public, private, and hybrid deployments. So we have customers who use our cloud to manage, deploy on the gateway, deploy it in there, close to services. So this is a really powerful product, and the about this product is it's also really easy to get going. They're very quick and easy to use. It's very powerful, but you can get up and running and offer APIs in production in under a month easily. And as you know, you can scale 1 billion transactions a day. 1 billion transactions a day, by the way, is 10,000 every second. That's 10,000, 10,000, 10,000, just like that. So what about security? Obviously, security is a question for a lot of people in the banking industry, but in many areas. And support encryption tokens, multi-authentication. We have fraud detection, real-time analysis. We have a step-up authentication protocols. So we can actually say this device or this person is logging from somewhere that we haven't seen them before. Now let's get them to pull out their mobile phone and prove who they are, and not just provide the normal login. And the guy who leads this is a guy called Prabhath. He's our chief security architect and the owner of our identity access management product. And he's literally on this. So this book, Advanced API Security, which is the leading book on API security, and he's just process of writing a new book called Services Security in Action. There's an early access version out now with the first 5 chapters if you're interested. As I was saying before, the world is moving to take APIs and turn them into products that can be resold. One of the ways of doing that is to create an API marketplace. This is where you aggregate APIs from multiple different organizations to provide a set of APIs that do more than any individual organization can do on their own. So example of this is quite popular is governments are doing this to try and digitally transform government. Governments are with large departments that talk to each other, and one way of solving it is not to try and use the same technology for everyone, but instead say we're going to have a single marketplace for all the APIs, and everyone can do their own thing, but backed by APIs. Another really nice example is, which is a mobile application marketplace. And I was telling you about the Axiata group with the 200 million cell phone subscribers throughout Southeast Asia. This is something they did. They built a mobile wallet, mobile identity, and a set of mobile APIs to enable people to build better apps, web and mobile phone apps. And having built that, you can use that in any of their geographies around Southeast Asia. So you can use the same work in Indonesia, in Malaysia, in Myanmar, all around the region. And they were like, well, this is cool, but we want people to build apps. So they built a marketplace where they could share the revenue with app developers. And this encouraged app developers to write APIs and apps. So the APIs they developed to build those apps could also be shared. So if somebody built a shipping API that was integrated, then other people could use that. And created 3,500 an API within the first 18 months with 2,500 developers on board. Just completely bootstrap a whole new development community around their system. Very, very exciting. So this takes us to, what is actually happening in the industry, and why are we getting these APIs and decomposition? And I'm not that well known for this, but I'm one of the first people ever to use the phrase cloud native. And I wrote a blog back in 2009, 10 years ago, called Cloud Native, and describing what we felt cloud native was in those days. And there's been multiple definitions. There's now the Cloud Native Computing Foundation, which is probably the biggest open source foundation at the moment, with pretty much every software company and many users. They have their definition. They actually had a really nice definition which they started with, which was microservice deployed network endpoint dynamically orchestrated cloud. They've made it all woolly and fluffy now. I don't like the new definition as much as the old one. My definition is very simple. My definition is that cloud native is the intersection of what happens when you decompose at the functional level. So we had DLLs, we had web services, we had APIs. So we're pulling things apart functionally. We're saying we can separate out the customer function from the shipping function, from the wallet function, into separate components. So that's the x-axis here. And we're pulling apart the deployment and infrastructure. When I first started coding, one of my first jobs was actually porting code from one machine to another. We had no machine interoperability. So now we got operating systems and Linux, standard libraries and C and POSIX, and then we said, okay, now we can virtualize that on different hardware, so I can have a Windows host and I can run Linux software on it. And then we had cloud and containers, and now we have Kubernetes. All of these things are pulling apart the physical layer. When you put those two things together, that's what cloud native is. And we have built, as Devika said, the first programming language which is really targeted at this space. Targeted at building native applications with APIs. So there are other great languages that are emerging that are helping you build network systems. So Go has a very, very nice concurrency model for building network systems. Rust has a very nice security model. But even if you look at those languages, they don't go as far as we think is possible in terms of saying this is a language optimized for writing and consuming network services. And that's what Ballerina is. It's a language that is designed entirely around, I want to build a network distributed system. I want to consume services. I want to write services. And what we did was we started with the sequence diagram. We do a project with a customer, we'd draw a sequence diagram, say, well, I'm calling here following me back, this is what it looks like. And so we started with that. Code, the code on the left there is generating that sequence diagram. If you really want, draw the sequence diagram and it'll generate the code. I'm more in code, I'm more of a CLI guy, so I prefer to go from left to right, but there are people who prefer to go from right to left. And by the way, this code you see here, that 27 lines of code, initiates a RESTful API, deploys it in Kubernetes, and calls out to Twitter to send a tweet. All in 27 lines of code. If you wrote that in Java, I think you'd probably have classes, you'd have several hundred lines of YAML to configure Kubernetes. Yeah, you know what I mean. You guys are laughing. Yeah, you know what I mean. And you can get a nice program out at the end of it. So this is a language really just these kind of scenarios where I'm taking data in over the wire, I'm calling out into multiple services, I'm orchestrating across it. And that's where the name comes from. So, you know, when you have an orchestra, imagine you're all the orchestra, you've all got your interests. There's one guy at the front standing saying, right, now you play, right, and telling everyone what to do. You have a play, the dancers interact independently. They've been coached by the choreographer ahead of time to work together, but when the choreographer's not sat at the front saying, do this, do that, the choreographer's sat at the back of the audience, and it's out of their hands. It's an independent set of independent people coming together to build something beautiful. And that's really what Ballerina's around. So that really takes me onto the Agile Manifesto and agility. And I really want to focus on one aspect of the Agile Manifesto, which says that the best architectures, the best code, the best understanding comes from self-organized teams. So if you really want to get agility, you need to have small, effective teams who understand the business domain, who understand the problem, and it's up to them to solve it. It's not a command and control. It's not the orchestra. It's not the conductor standing at the front saying, you do that, you do that, you do this. It's bottom up. And we all know Jeff Bezos' 2 pizza rule, right? Which is you have teams that you can feed with 2 pizzas. Now, this is an American pizza, okay? I don't know anything about South African pizzas, but I know in England, a 2-pizza team, people, right? We have small. But this means sort of a team with 8 to 10, 12 people max. And why is this? There's some science behind this. So this formula is the number of interpersonal relationships in a team of size n. So if I have 10 people in the team, I have 90 personal relationships between them all. If I add one more person, it goes up to 180. Right? If I add another person, it goes up to 360. It doubles every time I add somebody. And there's a whole lot of brain science in this. There's a guy called Dunbar who figured out that the number of interpersonal relationships you can manage is based on the brain size. So there's the size of the cortex stem. And the maximum is about 150. So, but obviously it's not just black and white. You don't have 150 great personal relationships. Typically you have 5 really close ones, 10 pretty good ones, 20, and 150 is the most people you can remember, clearly. And this is more focused research. This is someone who worked with knowledge workers in teams of between 10 and 20 and analyzed how they got on and basically found as the team size grows, something called relational loss. And what this is you don't really know the person. I'm not sure I can really trust them. Am I able to sleep well at night knowing that I'm relying on somebody and I don't actually know them at all? I've never worked with them before. I haven't got that close relationship. And so this is really the science behind why we need these small teams where everyone knows each other and can really be effective and trust in each other. So what is a self-organizing team? It's a team that manages its own work. It pulls work. It doesn't require that top-down command and control. They communicate effectively. It doesn't mean when I say manage their own work. I mean, they just decide one day, we were banking apps, but really we like to build a dating app, so we're going to stop making mobile wallets and create a new Tinder. That's not what it means. So teams need to have boundaries. They need to have structure. They need to have a mission. But once they have that mission, it's up to them to figure out the best way to do that. And this is really related to Conway's law. So Conway basically said, organizations that design systems will create systems that copy the organization. It's kind of wordy. Raymond put it better. You have four teams building a computer, you get a computer, right? That's the reality of it. Now, I've known this was written in 1967. I've heard of this. There was a famous book called The Mythical Man Month that I came across 30, 40 years ago. I guess not 40, I was a bit young for it then, but 30 years ago. And I have to say, I used to just kind of think, management, these idiots, it's their fault for not doing a better job here, right? I was like, we just need to build the right technology and all this organizational management stuff, that's idiot knowledge, right? Doing. And then I realized slowly that you can change human nature, right? We can change code, we can't change human nature. Maybe in 1,000 years we'll evolve to be better at working in larger teams, who knows? But at the moment, it's better to write code that fits the organization and to design around Conway's law than to try and fight it. And so that's really, I think, the challenge that we're seeing with Agile. So Agile is working well in small teams, and we're 69% of organizations surveyed doing Agile. The gap comes when we work across teams. The gap comes when we try and actually deliver it to the end customer, which often involves working across teams. And in this survey last year, only 4% of the survey that they were seeing that they were actually being agile to the customer, that they were seeing their whole organization adapt to market conditions. So that's kind of scary, isn't it? We're all doing agile, but we're not really making it happen at the customer boundary. And to me, this is all about organizing better and dealing with the cross problem better. So get the teams right and figure out how we work across. And that's really what the methodology that mentioned is all about. So I've been working on this with my deputy CTO, whose name is Asanka, and we've written this paper. And by the way, it's in GitHub. It's an open document. It's under a Creative Commons license, and we encourage people who have input to not just read it, but add pull requests, help us improve this. We run this the same way we run our open source. If you have contributions, we want them, because we believe this is not just us. And this is really about WSO2 technology. This is a general approach saying, how do we get people to be more agile at integration? According to Gartner, 50% of all digital transformation projects are consumed on integration. So integration agility is absolutely key to digital transformation. And what Asanka's really done, and I give him 99% of the credit for this, is to map out in the big, in the large, how companies can move to be more agile, not just in one dimension, but across their processes and technology. And understanding that you might do this or else. Maybe your legacy technology and you can't move that, so you're still that's holding you back, but you can get your teams and your processes more agile. Or maybe you've got great technology, you've moved to Kubernetes, you've moved to Docker, you've moved to CI/CD, you're using the micro integrator and the micro gateway, but your processes are still as Devika said, maybe you still have a very centralized integration team that is causing some waterfall to slip back in. One of my customers calls this, he says, sometimes people think they're doing agile, but they're really waterfall, and he calls it agile, which I think is a great term. So I think to add this other dimension to this cloud native, the other dimension is organizational. We need to make sure that we can effectively disaggregate the organization as well as the functional and physical to this composable enterprise. And we're seeing this all over the place. This is just to give you an example of disaggregation. 3 years ago, Uber published a blog saying they were doing several hundred microservices. They just started their microservices journey. This picture was posted at a conference about a month ago showing Uber's microservice graph today. And, it's obviously thousands. But what really scares me about this, I was the CIO of would be freaking out about this. I don't know if he's happy. But what scares me is the many-to-many connections across this graph. It's not the number of nodes, it's the number of lines stretching across many-to-many points here. And I don't believe, maybe they have some other organization they're not showing. So this is just the graph they showed at a conference. So I don't necessarily tell the story. I'm not dissing Uber, but saying that if you end up building something like that, I believe your CIO, CTO, or your architects, or even the developers are going to look at this and say, we've built a composable enterprise. This is too fine-grained and has too many point-to-point connections going on to really be composable and reusable. And that's where we take some inspiration from biology. So the fundamental unit of every biological thing is a cell. And if you look at this picture of cells, you see the boundaries. It's the boundaries that are important. The boundaries of cells allow cells to keep doing their job without interfering with cells. You might also ask, what about organs and other higher level constructs? I think we need to get there, but at the moment, I'd just be happy to get to the cell level. And the way cells work is this thing called the transmembrane receptor. So this is kind of an event-driven architecture. You have chemicals washing over the cell, and it responds to certain chemicals. When it sees that chemical on the outside of the cell, it signals through the cell boundary, and a new receptor is activated on the inside, something happens within the cell. So this is how cells activate, but more importantly, how to ignore anything else that doesn't matter to them. So the boundary is just as much about hiding the inside and not reacting to things you shouldn't, as it is to exposing the receptors on the outside. And this is fundamentally what I see a micro gateway as doing. So a micro gateway is a way of taking some of your microservices, some of your serverless components, and hiding them and creating a cell that has some reusable function. And I think this is based around teams. The self-organized team needs to be able to say, all of this stuff in my team, and I'm going to use a few well-defined interfaces to the rest of the world, and they can subscribe to those through management, they can activate those, they can use those. They don't need to know about my infrastructure. So this is about giving teams that allows them to be organized. And that's again a GitHub project, and you can download it. And we launched this over a year ago, and we keep iterating it. So we have a brand new release coming out that we think is even better. And that leads us onto this cell-based reference architecture. So about 18 months ago, Asanka and I started working on this along with our solutions architecture team and people. And we really see this as taking steps from things like driven design. Anyone read Eric Everett's Blue Book? So in that book, he talks about bounded context, but that's very much within an application. We think the same concept of bounded context aggregates needs to be kind of rewritten for the microservices world, which is really what this cell-based architecture is. And so we see cells as a compatible building block that lets you build a set of components in a highly agile way within a team, and then take them and deploy them and manage them as a unit with a well-defined place to the world. And this has gone down really well. We've had very, very positive feedback from our customers, from industry, from Gartner analysts, from all sorts of people. There's been one kind of thing that people say, so that's all very well, Paul. You know, how do I build this? The technology. And we're like, well, we've got API micro gateway, you've got Kubernetes, you've got service meshes, you've got all those components, we'll help you do it. And they're like, sounds like hard work. So that's where we've started a brand new project, and it's called Celery. And Celery is really designed to configure the micro gateway and the service mesh and Kubernetes to manage a cell as a single unit of architecture. And not just at time, but at build time, test, deployment, hot update, and management and observability. So what you see in this picture is some code that defines my cells. We build that image that you can push and pull into a Docker. You can now deploy that on Kubernetes, and that generates all the Kubernetes YAMLs and Istio service mesh YAMLs. So about 150 lines of cell definition generates 4,500 lines of YAML that you don't need to worry about. And this becomes a unit that lives throughout the life cycle of the thing. And again, we have a graphical representation of the cell that we build from your code to give you a higher level view. And you know, the vision of this, we're not quite there yet, but the vision is that you'll be able to look at your Ballerina components and see the sequence diagrams and then compose them into larger components and see the sequence diagrams. And actually, this is not just for Ballerina. So all our samples, for example, are built with Node.js as the language where you build the apps. You can use Spring Boot, you can use Go and Rust. So this is not just for WSO2 stuff. This is an idea of how you compose multiple different polyglot languages and systems into cells. So probably ran over time. Tendency to speak much, but I will summarize, and I think the first point is the most important. Aggregation is inevitable. Your integration problem is only going to get harder as we disaggregate into more and more fine-grained components. So integration is going to become a bigger and bigger challenge. And cloud native and APIs and the right teams give you agility. So when you put those things together, that's how you generate this agility for your integration. And to do that, I think you need the right boundaries. So API strategy is really important when you're building how we do our digital transformation, how we partners, how we open up our business, we create new opportunities. But the second aspect of it is, how do you build organizational awareness? To me, that is by using APIs and API portals as of managing the inter-team boundaries as well as the inter-organizational boundaries. And we've created what we think is the first language that's designed truly to deploy APIs and create APIs in an agile way in a cloud-native environment and to really help you build that glue. We're very excited about it. As Devika said, we're going to launch the 1.0 of Ballerina this summer. So that's going to be an exciting moment for us. We've been working on this for a few years. And I also think that this model really helping take that mess that's starting to appear in the microservices architecture, so that and try and build higher level constructs in context that you can deploy and manage to give you a real composable enterprise. So I hope you've enjoyed this, and I hope the rest of the day goes well. I'm really excited to hear, especially from our customers. I think that we're going to hear some very exciting stories about how they're taking this technology and really solving some of the problems here in South Africa. So thank you very much.